So let's understand the difference between these two very, very important terms in probability, which are population and sample. I'll try to explain these concepts with an example. Let's imagine this circle is the set of all is the set of it's a set of all the people, it's a set of all the people in the world. Okay, so this is called the population. Now let's take a simple example. Imagine if I want to estimate the average human height, the average height of a human. Okay, imagine that to be my problem that I want to solve. What is one way to solve it? Imagine this is the set, this big circle here. Imagine if this is the set of all the people in the world, right? That like almost 7.5, almost 7 billion plus people today. To actually estimate the average height of the human, you have to take each human being, okay, sum up all the heights of the 7 billion people, right? It is basically summation of heights of each person I, where I goes from 1 to 7 billion. This is almost impossible, right? This is, I mean, you can't measure 7 billion people and take the average. Okay, this is the average population uh, height, right? So the mean we often write the mean of, so mean height. So here in this case we want the average or the mean height of all human beings. We often represent the mean of a population. So this is mean of a population. So we write mean of a population typically as, we often write it as mu, the mathematical symbol mu. Now it's impossible to do that. Okay, since we cannot compute the mean height of all humans by measuring every human being here, we want to estimate it. That's the interesting part here. We want to estimate the average or mean height of humans, right? So to do that, what do? We can take a sample. Okay, you understood what is a population? This is the population. This is the population, right? Since we can't measure all the 7 billion humans, I can take a sample. Okay, I can take a sample. So this is called a sample, right? So a sample, I can say, okay, I will take, so sample is like this. I can take, it's sample of, let's say, size 1000. I can say that since I can't measure heights of all the 7 billion people, I will take a random sample. So that's called, so a sample is basically a subset. A sample is basically a subset of the population. A sample is a subset of the population, right? So I can take a sample of users. Let's say if I take a sample of 1000 users, as I just mentioned here, from these 1000 users, I can measure their average height. So I can do something like this: 1 by 1000 multiplied by summation I equals to 1 to 1000 of all the heights in my sample. These are heights in my sample. Heights in my sample. Now, if I collected my sample, here, remember the words that I'm using. If I collected my sample in such a way that I have randomly picked 1000 people here, okay, such a sample is called a random sample. Such a sample is called a random sample. So when I take a random sample of 1000 users, I should get roughly, because 1/6 of the world population comes from India, so roughly about 1000 by 6, right? Which is about 160 odd people should come from India, right? So you need to, in a random sample, you need to ensure that you're getting people from all regions of the world in the proportion that they are in the population. Okay, that's what happens when you take a random sample. Now this is often written as H bar. So because each of my variables is called Hi, we often write it as H bar. If I wrote this as Xi, I write it as X bar. Okay, so typically symbols like this are used to represent the mean of a sample. The mean of a sample. thing to note is, as the sample size increases, as sample size sample size increases, when it becomes fairly large, your mean becomes equal to your sample mean. This is your sample mean, right? Your sample mean becomes equal to your population mean. Okay, as sample size increases, obviously, right? Instead of 1,000 people, if you take 1,000,000 people, as the sample size increases from 1,000 to 1,000,000, your sample mean will converge towards the population mean. Okay, it will come closer and closer. It will become closer and closer to your population mean. Okay, so in this video, we wanted to understand the difference between what a population is and what a sample is. Okay, so population is a set of all the events or all the observations, while a sample is a subset of the population which you have taken to estimate, to make an estimation about some statistic or some property of the population. Okay, here that property or statistic is the height. So we wanted to compute the average height of the humans, right? So this height is called a property, or a statistic that we want to measure for the population. Again, I'll keep using these terms population and sample. Whenever you encounter them, just think population means the universe of all the things, and sample is a subset of the population.